Hello teachers, learners, and parents. Sir Jeff po, at your service. Alam nyo ba na meron tayong website na tinatawag na DepEd Commons? Ang DepEd Commons ay binuo upang gawing accessible ang pagtuturo at pag-aaral dito sa ating bansa gamit lamang ang inyong mga smart devices gaya ng cellphones, tablets, at computers. Dito ay maaari nating ma-access ang iba't ibang learning materials mula sa Department of Education. Meron itong mga interactive materials, electronic self-learning modules, at instructional video lessons mula sa DepEd TV na tiyak na makatutulong sa pag-aaral ng mga mag-aaral galing ka man sa public o private school. Walang problema dahil welcome ang lahat dito. Para ito sa mga guro, magulang at mga mag-aaral mula sa kinder hanggang grade 12, alternative learning system o ALS, at pati na rin ang special education. At huwag kang mag-alala dahil kahit walang load ay maaari mong ma-access ang mga learning materials. Tama! Libre ito. Ang kailangan mo lamang gawin ay i-on ang iyong data at buksan lamang ang iyong browser at i-type ang commons.deped.gov.ph. Alam na ba ng iyong mga kasamahang guro o mag-aral ang tungkol sa DepEd Commons? I-share mo na ang video na ito upang matuto rin sila kung paano gagamitin ang DepEd Commons sa mabilis at napakadaling paraan. Muli, ito po si Sir Jeff at kita-kits po tayo sa DepEd Commons. Paalam!
Magandang araw, Sir Wilbur po, at your service. Narito ang ETUlay upang gabayan ka sa inyong pag-aaral upang lubos na maunawaan ang iba't ibang paksa o subject. Ang ETUlay ay isang free online tutorial class na pinangungunahan ng ICT's Educational Technology Unit sa pamumuno ni Undersecretary Elaine Del B. Pascua. Ang programang ito ay hindi lamang para sa mga bata, kundi ito rin ay magsisilbing gabay sa mga magulang at mga guro kung paano nila ituturo o gagabayan sa bawat asignatura ang kanilang mga anak o mga estudyante. Sa kasalukuyan, ang self-learning module mula sa rehiyon ng Calabarzon at kilala sa tawag na pivot ang ginagamit sa ating ETUlay online class. Kaya ano pang hinihintay ninyo? Ihanda na ang inyong mga ballpen o lapis, papel o kwaderno at samahan kaming itulay ang pagkatuto para sa bawat batang Pilipino. Sama-sama tayong magtutulungan para malampasan ang mga hamon sa panahong ito. Halina't matuto kasama ang inyong online tutor sa oras na ito.
Magandang Lunes ng hapon po sa lahat ng ating mga masugid na taga-subaybay sa ating ETUlay sessions. Welcome po to another ETUlay session. Tutor Lester po, at your service. Right. We are on the 4th week of the final quarter of this school year. 4 weeks more to go na lang at may tatawid na rin po natin ang isang napaka-challenging na school year. For this week, we will discuss dual nature of electrons and the wave nature of light. Our objectives for this session are the following. Describe a particle and a wave. Identify key persons and their combinations and their contributions in the development of the wave-particle duality theory. Define wave interference, diffraction, dispersion, and scattering. And as usual, magsisimula po tayo sa ating tutorial session with a 5-question pretest. Simulan po natin sa unang katanungan, mga kaitulay. A minute portion of matter and was known as the smallest building block of the universe. A particle, B. Photon, C. Portion, D. Product. Tamang sagot po ay A. Particle. Question number 2. The theory that states all matter and light shows in the characteristic of both wave and particle. Dual wave portion theory, wave dual particle theory, C. Wave particle duality theory, D. Duality of wave product theory. Ang tamang sagot po ay letter C. Wave particle duality theory. Pangatlong katanungan. A point particle with a negative electric charge. A. Atom, B. Electron, C. Neutron, D. Proton. Tamang sagot po ay letter B. Electron. Number 4. A disturbance that travels through space-time. A. Diffraction, B. Photon, C. Reflection, D. Wave. Ang tamang sagot po ay letter D. Wave. Number 5. And the last question. He was the first to coin the term electron for the electric charge quantity. A. Albert Einstein, B. Christian Huygens, C. Joseph John Thomson, D. George Johnston Stoney. Tamang kasagutan po ay letter D. George Johnston Stoney. Alright. So we'll start with our discussion on whether an electron is a particle or a wave. So how is the universe built? So as we all know, the universe is built upon this minute portion of matter, which we know as particles, right? So everything that makes up matter and the universe is called particle. So I think we can already define what an electron is from what we have learned in our junior high school science. So how much do we know about electrons? You, ano po ba ang nalalaman nyo about electrons? What do you know about electrons? So let's start with the first scientist on the list. So it was George Johnston Stoney who first coined the term electron as an electric charge quantity in 1894. Then it was followed with Joseph John Thomson identifying electron as a particle. So in identifying electron as a particle, he uses the cathode ray tube experiments. So in this slide, what is shown to you is Rutherford's atomic model showing where the electron is supposedly located in an atom. So dito po sa ipinapakita pong illustration, we can see here that the electron are shown to be orbiting around the nucleus of the atom. So the electron is a subatomic particle na merong negative electric charge. So it has no known structure and it is believed to be a point particle. Its mass compared to a proton is about 1,836 less than the mass of a proton. So it was implied in our previous slides that an electron is a particle. So where does the idea of electron being a wave come from? So saan po nanggaling ang idea na ang electron ay isa ring wave? So let us first define a wave. So actually, we have already mentioned this in our previous discussions dito sa ETUlay. So in physics, a wave is described as a disturbance that travels through space-time and medium. And this is accompanied by transferring energy from one place to another. Speaking of medium, the medium may be a substance or a material that carries the wave. So a medium can be air, can be water, or other objects. So the wave medium, such as the air and water, does not actually make the wave. So it only transports the wave from the source to other locations. So I have here a short video clip. So it can be seen here what a wave does. All right, let us view this short video clip. Right. So it can be seen in our short video clip that the coil is, when the coil is stretched, the coil assumes an equilibrium or rest position. And when it is repeatedly vibrated back and forth, you can see a disturbance is created, which travels through the slinky coil from one end to the other end. So yung disturbance na nakikita nyo po, okay, that is the wave. So an electron being a particle, so how can an electron, which is a particle, yet exhibit a wave-like behavior as shown in the video? So paano po nangyari yun? Okay. So first, let us recall in the previous week that we mentioned the scientist Christian Huygens as the proponent of the wave theory of light. So it was in 1678 in which Christian Huygens proposed the wave theory of light, in which, according to his proposal, okay, light is made up of waves. Then, in 1803, Thomas Young studied interference of light waves using the double-slit experiment. So dito po, in Thomas Young's experiment, so we can see here, okay, this is his setup. So he's shining light through a screen with two slits, okay, which are equally separated. All right. So the light emerging from these two slits will spread out. Okay, it will spread out according to Huygens' principle. So eventually, okay, ito pong two wavefronts natin. Okay, we have here a wavefront here and another wavefront here. So this will overlap each other. So this experiment eventually supported Huygens' wave theory of light. And in the early 19th century, diffraction of light had been observed, which firmly support the wave theory of light over Newton's particle theory. So this term, diffraction, was first coined by Francesco Grimaldi, an Italian natural philosopher. And then in the year 1900, another scientist, Max Planck, proposed the existence of light quantum. So in this theory, okay, a finite packet of energy which depends on the frequency and velocity of the radiation. So the birth of this, the birth of quantum physics is attributed to this, to Max Planck's experiment on black body radiation. Then in 1905, Albert Einstein proposed a solution to the problems of observation made on the behavior of light having characteristics of both wave and particle theory. So he used the works of Planck on the emission of light to form hot bodies. It was then Einstein suggested that light is composed of tiny particles called photons. And each of these photons has energy. So this finding of Einstein came to be known as the photon theory of light, which later led to the conceptualization of the quantum mechanics in the early 20th century. Then in 1924, another scientist, Louis de Broglie, made a bold assertion proposing the dual nature of light. So this time, light is both a particle and as a wave, in which later was extended to particles such as electrons, atoms, and molecules. So de Broglie related the wave property and the particle property in this equation. So in this equation, we have here lambda is equal to h over mv, where lambda is the wavelength, h is the Planck's constant, m is the mass, and v is the velocity. Excuse. Then in 1927, we have two scientists, namely Clinton Davison and Lester Germer, perform an experiment which would confirm de Broglie's prediction. So the experiment in which the electrons scattered by the surface of a crystal of a nickel metal displayed a diffraction pattern. So that diffraction pattern confirmed the hypothesis advanced by Louis de Broglie in 1924, which is the wave-particle duality theory. And this confirmation was an experimental milestone in the creation of the quantum mechanics. Right. And now let us discuss the different phenomena of light. So last week, we had already mentioned dispersion. All right. So we can see here, okay, dispersion is the separation of white light into several colors or wavelengths. So dispersion occurs because, okay, as we all know, in refraction, the speed of light changes from one medium to another. So let us say, for example, okay, from air to this prism. So the speed in air is different compared to the speed of light in the prism. So mas mabagal po ang speed of light when it enters through the prism. That's why you can see, okay, the slight bending of light. And then when white light enters the prism, you can see different colors in different angles as it travels in the prism and as the dispersed light emerges from the prism. Okay, additional information. So we have already mentioned that there is a difference between, okay, the angle of the incident light that hits the prism and then the angle of refraction as the dispersed light emerges from the prism. So tinatawag po natin itong deviation na ito as the angle of deviation. So the angle of deviation as defined here in the slide, this is the angle made between, okay, the incident ray of light entering the, okay, first phase of the prism. Ito po yung first phase ng prism. And then the refracted ray that emerges from the second phase of the prism. Okay, so the difference between the angle of the incident angle of the incident light that hits this side of the prism, and then the angle of refraction created by the light exiting through this surface of the prism. So when okay, so let us define interference. Okay, this is the phenomenon that occurs when, okay, two waves meet while traveling along the same medium, right? So, okay, I think I have already given this as an example in the previous slide. Okay, let us watch this short video clip again. All right. So napanood po natin, okay, we were able to watch the waves in the spring, okay, meet. So nagsasalubong po ang dalawang waves, okay, as the slinky coil is vibrated back and forth. So, okay, from what you have observed in the slinky coil, ano po ang nangyayari when these two waves meet? So, do this wave destroy each other, or do they create a much bigger wave? Right? So there are, okay, what is this? There are two instances in which these two opposing waves may create. Okay, so first is constructive interference. So there are two types of interferences that happens when these two waves meet each other. So the first one is constructive interference. So this happens when, okay, two waves in phase meet and produce a larger amplitude wave. So para mas maintindihan po natin kung ano po ang sinasabi ng constructive interference, okay, let me share to you this another short video clip. Right? So, makikita po natin sa short video clip that I have just shared with you. So, it shows a constructive interference between two waves. So, as these two waves meet, they produce a wave with a much larger amplitude. Okay. Then, another type of interference is the destructive interference. So destructive interference, so this results in the cancellation of wave or the reduction of the wave amplitude. So this cancellation of wave or the reduction in amplitude depends on how out of sync these two waves are. And again, to show you an example, okay, let me share to you, okay, another short video clip that shows destructive interference. Right? Okay. So it is clear, okay, it is clear that in this short video clip, we can clearly see how two waves that meet, okay, that meet, canceling each other out. All right. Okay, next we define the diffraction phenomena of light. So what is diffraction? So a diffraction happens when, okay, the light wave bends around the corner, right? So diffraction is the bending of light waves around the corner, as shown in the illustration in this slide, right? So it is shown here that light is bent around the corner. Okay, makikita po natin. So these are okay, so these are the wave produced. Okay, meron po tayo ditong slit dito sa gitna. Okay, there is a gap here. Okay, so when wave hits the barrier and some of the waves made it through the slit, so the light wave bends around the corner. Okay, so these are the light that is being diffracted. Right. Okay, so this is diffraction using a single slit. Okay. If light passes between two slits, so this time may dalawa pong may dalawa pong butas or dalawang hole. So when the incident light or the light passes these two slits, okay, we can see here that the incident light, okay, diffracts around the corner of these two slits, and as we can see, the emerging light from this slit interfere with each other. Right. And now let us discuss the scattering of light phenomena. So the scattering of light, this is a phenomena in which, okay, light rays gets deviated from its straight path on striking an obstacle like dust or gas molecules, water vapors, and etc. So the scattering of light gives rise to many spectacular phenomena such as Tyndall effect and the reduce of sunrise and sunset. So ito pong scattering of light, this explains why we can see the sky as very red during sunrise and during sunset. Okay, so let's start with Tyndall effect. Okay, so Tyndall effect, this is a phenomenon of scattering of light by colloidal particles. So Tyndall effect, okay, this phenomenon, okay, it is used to identify a true colloidal solution. So we get to see the Tyndall effect in our surroundings very often. Okay. Right. All right. Okay. So what you're seeing here is a short video clip that demonstrates the scattering of lights by colloidal particles. So this scattering of light, okay, this setup here is used to identify a true colloidal solution. All right. Okay, let us continue watching this short video clip. Okay, ito po yung my colloidal solution and this is pure water. So, as you can see in this short video clip, the Tyndall effect, the colloidal particles is clearly scattered, the light is clearly scattered by the colloidal particles. So, makikita po natin that the pure water cannot scatter the light particles, whereas on the other setup, okay, where it is a colloidal solution, so it was able to scatter the light. Right? Then another phenomenon of the scattering of light is called Rayleigh scattering. So this refers to the scattering of light of the molecules of the air. So, and can be extended to scattering from particles about a tenth of the wavelength of the light. So Rayleigh scattering only occurs when the particles are smaller than the wavelength of light. So it is the Rayleigh scattering which explains why we can see a blue sky and why we can see a red sky during sunrise and sunset. And again, okay, this is a short video clip that explains how Rayleigh scattering happens in a fiber optic wire.
Rayleigh scattering, the elastic distribution of light in all directions, which is caused by interference with particles smaller than the wavelength of the light itself.
All right. So that short video clip explains how Rayleigh scattering happens in a fiber optic wire. All right. So as I have mentioned, okay, it is Rayleigh scattering that can explain why we can see a blue sky and why we can see a red sky during sunrise and sunset. All right. So now let me give you this summary of the things I have discussed for this week. So first, electron both exhibits wave and particle properties. Second, the different phenomena of light the light exhibits are the following: okay, dispersion, diffraction, and scattering, which includes Tyndall effect and Rayleigh scattering. Alright, so at yan po ang ating tutorial session for this week. So sana po nakatulong po ang ating tutorial session dito sa ETUlay para mas maintindihan nyo po ang inyong self-learning module sa Physical Science for Week 4. Ilang linggo na lamang po at may tatawid na naman po natin ang school year. So ito po ang inyong tutor sa session ito. Tutor Lester po, at your service. Kita-kita po ulit sa susunod na linggo sa parehong oras. Para sa bata, para sa bayan. Magandang hapon po.
Sigurado ako na marami ka na namang natutuhan sa ating ETUlay tutorial session ngayong araw. Tandaan, ito ay hindi lamang para sa ating mga mag-aaral, kundi pati rin sa ating mga minamahal na guro at mga magulang na kaagapay natin para maituloy ang pagkatuto sa kabila ng nararanasang pandemya. Patuloy ding sumubaybay sa DepEd TV para sa mga araling ginawang video episodes. Mapapanood ito mula Lunes hanggang Sabado, alas 7 ng umaga hanggang alas 7 ng gabi sa inyong mga telebisyon. Abangan bukas mula alauna ng tanghali ang iba pang aralin sa ating ETUlay free online tutorial session sa English. I-like and subscribe at manatiling nakasubaybay sa ating ETUlay tutorial session sa DepEd Edtech Unit FB page at Educational Technology Unit channel sa YouTube at sa DepEd Tayo at DepEd Philippines social media accounts. Paalam!